So we need a Pico and a breadboard, we need some jumper wires, and we need some individual LEDs and resistors.
So this is a great tutorial if you're quite new to Raspberry Pi Picos and are still getting used to how to use a breadboard, jumper wires, and to connect hardware, in this case LEDs, to it. If you want to go straight to the code, if you jump ahead, otherwise this will walk you through how to use these things.
Okay, so we've got our breadboard with a Raspberry Pi Pico connected to it. We've got a couple of jumper wires, we've got a resistor, and we've got a single LED. So we're going to plug the LED in first. So the longer leg is the plus. It matters which way round they are. So the longer one is the plus, called the anode, and the shorter one is the minus, called the cathode. So longer plus anode. And just before we plug in, a little reminder about how these breadboards work. So these 5 are connected in a row, these 5 are connected in a row, this one is not connected to this one.
So it's worth just having a little look at the back of a breadboard to really understand how they connect up different components, and that is the point of a breadboard, is to avoid having to solder and connect loads of wires together, which slows everything down. So these rails here match up to the 5 lines of pinholes in the front of the breadboard. And as mentioned before, you've got the plus and minus rails at the sides of the breadboard.
Okay, so these 5 are all connected to each other. Right, okay, so let's connect our okay, so the right one is the plus. That's connected to, it's not connected to anything at the moment. So now we're going to connect our resistor. Okay, this is a 330 ohm resistor. Do we really need resistors? It might work without it, but they have a tendency to burn out because the power output from the Pico is 3.3 volts. So that might be a bit much. So this just slows the current down a bit. I'm going to go from the short leg to the negative rail along here. So any one of these could be this one, could be this one, could be this one, could be this one. Okay, so I'm just going to connect it and then loop it down to the minus rail. So there you go. Clear as mud. Right, so what's the next step? So we're going to connect the plus, the anode side of the LED to the Pico, because we're going to send a signal from the Pico to the LED, and then it will continue on the negative rail to finish off. So first of all, I'm going to connect my jumper wire. Any one of these, as mentioned before, they're all connected together. So that will work. So this I'm going to connect to here. So this jumper wire is now connecting to this pin.
So what you can see here is a pinout diagram for a Raspberry Pi Pico. In the top left hand corner you can see the label for the pin GP15, general purpose in out pin 15, and we need that when we write our code. You will see that we are going to send an instruction through the software that turns that pin on.
So imagine power is going from this wire into the LED and then out of the negative side, the cathode side, through the resistor onto this blue rail and all the way down, and we need to connect this blue rail to the ground pin on the Pico. So the ground pin is the third one in on the right hand side, and when I'm doing my breadboards I always try and make sure that this USB micro USB connection is to the right. Just helps me to orientate. So 1, 2, 3. So that's now connecting this wire to the third pin, and then I can connect it anywhere onto, it could be anywhere along here. This whole rail is connected. Okay, so that one is fine. So that's now basically completed a circuit going from this point, this pin on the Pico, and we'll program it to send a signal onto the longer leg, the anode of the LED, and then it'll go through the LED and out the other side onto the shorter cathode, through the resistor to slow it down a bit, along this rail to this jumper wire, and that goes to the third pin on in from the end, which is the ground pin. As always, we are using the Thonny IDE Integrated Development Environment. That's the software we're using to write Python with. You need to connect your Raspberry Pi Pico with a micro USB cable, and then you need to click in the bottom right hand corner to select the MicroPython brackets Raspberry Pi Pico. Now I always like to run some really simple test code that doesn't rely on anything I've plugged in to the Pico. That's because sometimes there are bad connections, or something's wrong with the breadboard, or there's a busted LED. So let's just check our connection to the computer is working properly before we start using any of this plugged in hardware. So I'm sure you remember we need these libraries, so this allows us to talk to the pins on the actual hardware, the Pico. This is the time library so that we can pause our program at times, and this is connecting to the onboard, the built-in green LED that is actually built into the Pico hardware. So now we've got a variable for that built-in LED. We can actually tell it to switch on and off. So one is on. The time.sleep is important because if we turn it on and we just turn it off straight away, it will do it in the blink of an eye and we won't even see it switch on. Okay, so now let's test our program, see if the onboard LED lights up. Okay, that worked well. That tells us that the connection to the Pico is working well. Now we can start moving on to trying to make this red LED light up. GP15 is the number that we're interested in for this pin. So why am I banging on about that? Well, we need to be aware that this pin here is GP15 because we're going to write that into our program now. So we're not using the onboard LED anymore, so we're not going to have these values. We're going to link to GPIO GP15. We're sending a signal out of the Pico, so that stays. And then much like we did with the onboard green LED, we are writing similar code.
Okay, the moment of truth. Let's test our program. Yes, and it worked. So if we do it again, we can see that the red light came on for 3 seconds as we wanted it to in here. Okay, now it's time for you to apply your knowledge. Can you pause this video and make the LED flash 3 times? So the simplest way to make your LED flash 3 times would be to repeat the code 3 times, and you can see on line 5 the LED is told to turn on, and then it pauses for half a second, and then the LED is switched off, and then it pauses for half a second. Sometimes people forget line 8 and jump straight from line 7 to line 10, but that would mean it would go off and on instantaneously almost. However, there are a lot of repeated commands in this sequence, so we can do it much more efficiently with fewer commands using a for loop. So notice that we say the for loop is going to loop 3 times on line 5, and then we repeat the indented lines 6 to 9 in that looping of the for loop. Well, the next step would be to plug in 2 individual LEDs and wire them up, and then write programming for them. And we will also move on to using LED strips, which you can program to be different colors and brightnesses and look like they move and zoom and things, which is great fun. And you can make buttons, control them in various ways. So all the components you can now see on the screen are really inexpensive and cheap, and the idea is that you can explore and build and create programs for all of these inputs and outputs. So you've got motors and servos, you've got buttons that you can make input into the system and produce different outputs, you've got different displays, and you've got sensors such as this ultrasonic sensor. So you can create burglar alarm systems, or a box that opens automatically, or a robot that responds to nearby objects. Really looking forward to working on these projects with you. Please do feel free to subscribe or leave a comment. That's really helpful, obviously. And I hope you're enjoying the creativity of physical computing using the Raspberry Pi Pico as much as I am. Well done for reaching the end of the tutorial. This was quite an important exercise, really, because it's the first time we've used a breadboard, and we were connecting hardware like LEDs into the breadboard and using jumper leads to connect them to the pins on the Pico, and then we wrote programs, sent commands from those pins to the connected hardware, and we're going to use that principle a lot in the future.